Bringing websites to life with JavaScript. About this course. Welcome to the Bringing Websites to Life with JavaScript course. In this course, you'll learn how web developers use JavaScript with HTML to create dynamic websites. You'll examine JavaScript syntax and how variables, functions, expressions, and events operate in JavaScript code. You'll explore how web developers use data in websites and MySQL code to work with the data. You'll also learn about Node.js and the advantages of using frameworks and libraries. Prerequisites. Before starting this course, you will need knowledge of the basic functions of a computer and the layers of computer architecture, the structure of HTML, CSS, and JavaScript. You can gain this knowledge by completing the Web Development Basics and Developing Sites for the Web courses in the Web Development Fundamentals Learning Plan. Learning objectives. After completing this course, you should be able to explain JavaScript syntax, identify techniques web developers use to include JavaScript in HTML, compare and contrast different programming models, explain how to use code objects, explain how variables, functions, expressions, operators, and events operate in JavaScript code for dynamic websites. Define common types of data. Identify the 4 primary database functions. Recognize simple MySQL syntax to create a database and work with data. Explain the purpose and function of Node.js. About this module. Module 1. The Dynamic Web, an Introduction to JavaScript. Introduction. In this module, you will learn about JavaScript as a full-stack language and explore how web developers use it. You'll learn how to use JavaScript in HTML documents to make changes to the documents or respond to user actions on the web page. Learning objectives. After completing this module, you should be able to identify the functions of JavaScript, identify ways to include JavaScript in HTML documents, describe how to use JavaScript to modify an HTML document, recognize the purpose of the Document Object Model, DOM. Explain how to use JavaScript to respond to events on a web page to make it dynamic. Bring it to life, JavaScript and its uses. JavaScript is a powerful programming language that enables web developers to change the content on a website based on events, change a website's style, and even manage data and provide feedback to users. Whenever you fill out a form on a website or use an interactive map, it's likely that JavaScript code is running behind the interaction. When you browse a website that uses JavaScript, your browser downloads the JavaScript files and runs the code inside them to perform specific actions. Your browser is programmed to understand what to do with the JavaScript files, which enable the browser to perform the functions specified by the web developer. As well as running in a browser, JavaScript code can also run on a web server using a runtime environment. A runtime environment includes the operating system and any other software or resources that a program needs to run. In this sense, both a browser and a server are runtime environments. Each runtime environment can do different things. However, due to its ability to run in both browsers and servers, JavaScript is a powerful language with many uses. Browsers mainly use JavaScript to make web pages dynamic. A web page is dynamic when users can interact with the content, for example, watching videos, editing photos, modifying data, and even doing something as simple as clicking a button. Use JavaScript with HTML. JavaScript is a programming language, so when you write JavaScript, you're writing code. The concept of putting code in HTML might sound odd, but the ability to add JavaScript to your HTML document is extremely powerful. JavaScript is an interpreted language, which means that while loading a web page, the browser reads the JavaScript you write and then runs each line one at a time. Developers include JavaScript in the body or head sections of their HTML document or load JavaScript from an external file. In what follows, you'll explore how to include JavaScript in an HTML file using each of these approaches. Include JavaScript in the body of an HTML document. Developers can include JavaScript in the body of an HTML document by using a script element. They write JavaScript between the opening and closing tags of the element. It's not necessary for developers to tell the browser that the script element contains JavaScript. Browsers are engineered to figure it out. However, adding an attribute of type equals text/JavaScript is good practice for readability and makes it easier for the browser to use the script. Here's an example. Alert, this is a JavaScript message. Including JavaScript in this way is not a best practice for live websites. Because HTML files load sequentially from top to bottom, if the elements in the body need the script to run before the page loads the script, the page might not work as expected. However, for the purpose of testing code or giving a demonstration, this is a quick and easy way to include JavaScript in an HTML document. Include JavaScript in the head of an HTML document. Including JavaScript in the head section is similar to using JavaScript in the body, except the script element is placed in the head. Web developers commonly use this method to add JavaScript to an HTML file because it offers many advantages. The key advantage of including JavaScript in the head is that because the browser loads the content of the head section before the rest of the page, any code included in it will load prior to being called. Here's an example. Alert, this is a JavaScript message. Include JavaScript from an external file. You can also write your JavaScript code in an external file and use it from your HTML document. Web developers prefer this approach for including JavaScript in web pages, and it makes managing JavaScript code easier. This approach also makes it easier to work with other team members on a web development team. Some members of the team can work on the JavaScript code while others work on the HTML and CSS. JavaScript files have a .js extension. These are plain text files, and web developers can create them using a text editor or an integrated development environment, IDE. To include the JavaScript file in the HTML file, developers place a reference to the external file in the head section of the HTML file. The script element uses the src attribute to identify the name of the JavaScript file. Here's an example. Now that you've learned how to include JavaScript in an HTML page, you will learn how web developers use JavaScript to modify HTML. Use JavaScript to modify HTML. Developers can use JavaScript to manipulate existing page styles and even dynamically replace the entire CSS style sheet. If they assign an ID to an element, they can use JavaScript to find elements by that ID and then modify the element. An ID is a case-sensitive string that identifies a specific element, and only one element can have that specific ID. Explore the following example to see how this works. Build the HTML page. Suppose you build a page with a section that looks like this. Modifying HTML with JavaScript. JavaScript is powerful. It can manipulate HTML. This simple web page shows a header and 2 paragraphs. The header text is bold and slightly larger than the paragraph text to make it stand out. Add a script element to the page. Now, suppose you want the text of the second paragraph to turn red when a user loads the page. You can use JavaScript to do it. A simple way to add JavaScript to a page is to use a script element in the body of the HTML document. Adding JavaScript in a script element is a good way to test code and experiment, so this example uses the script element in the body of the HTML document. To add JavaScript to a page, first create a script element. This tells the browser that the content of the element is code that the page needs. Modifying HTML with JavaScript. JavaScript is powerful. It can manipulate HTML. Add JavaScript code to the script element. Next, add the JavaScript code to your script element. The JavaScript command, document.getElementBid, para2.style.color equals red, searches for the element with ID para2, then changes the color of that text to red. You can place the command inline in the HTML document like this. Modifying HTML with JavaScript. JavaScript is powerful. It can manipulate HTML. Document.getElementBid, para2.style.color equals red. That's a simple example of how to use JavaScript to change the HTML document object model, DOM. The DOM is the structure of the HTML and includes all the elements on a page. Keep going to learn more about the DOM and how web developers can change it to make their pages more dynamic. The Document Object Model, DOM. Large shopping centers have many shops and services. Some have a food court where you can get something to eat. Most have large stores with many smaller shops between them. Most have services like restrooms, parking lots, and security offices. Finding what you want in a large shopping center can be difficult, so the centers provide a map so you can find stores by category. You can also see all the services on the map, which helps you discover where to find a restaurant or transportation. The DOM in HTML functions in a similar way. It's a type of map of the entire HTML document that shows what kind of components the document contains and where to find them. The DOM also enables web developers to interact with it by using interfaces. Earlier, you learned about the JavaScript command called getElementBid and how to use it to find an element by its ID and then change the style of the identified element. This is an example of an interface. The element ID is a part of the DOM and the getElementBid method enables developers to find and then change or modify the element. JavaScript uses the interfaces provided by the DOM to make changes to the HTML. By using DOM interfaces, developers can find, change, add, and remove elements, attributes of elements, and events on elements. You've learned so much already. Check your progress by putting the steps for creating a JavaScript element that modifies HTML in the correct order. In the next lesson, you'll explore how to use JavaScript to respond to user activity on a web page. Use JavaScript to react to user actions. When completing online forms, you'll sometimes see a red error message display alongside a required field that you have left blank. Or you might notice a link change color from blue to purple when you select it. These changes to the page are called events. Events are system changes that occur. The reasons for these changes include a change in data, a user interaction, or an error. Developers can use JavaScript to respond to such events. To write JavaScript code to respond to an event, developers create an event handler. The web browser listens for events. So, when a user clicks an element on a web page such as an image, the browser's code is aware of the click happening. However, it's up to the developer to handle the event and define what should happen when it occurs. There are two main steps in creating an event handler in HTML and JavaScript. This example uses the onClick event that happens when a user clicks the element, but there are many other events that developers can handle. Create the event listener. First, create an element with an onClick attribute. This attribute is the event listener for the event, which tells the browser to do something when the user clicks the element. This HTML code goes in the body of the HTML document. Here's an example. The event listener points to a JavaScript function called myClick function. A function is a set of JavaScript code that enables you to pass data to the code and get data back from it. Create the event handler. Next, create a JavaScript function with the name you used for the onClick attribute. In this case, use myClick function. You define a function by using the keyword function followed by the function name. After the function name, add open and closing parentheses and then write the JavaScript code for the function between a pair of opening and closing curly braces. You can write this function inside a script element in the head or body elements of your HTML document or in a separate file. Here's an example. Function myClick function. Alert, this is a JavaScript message. These are the basic steps for creating an event handler in JavaScript. Build a dynamic web page. In the following expanded scenario, you'll learn how HTML, CSS, and JavaScript work together to build a dynamic web page. The following scenario shows how a web developer would build a web page to demonstrate the onClick event attribute. Notice how they use the event attribute of a division, div, element and how they reference the JavaScript function from that element. Step 1. First, the developer creates the div element in the body section of the web page. The onClick event attribute reacts when a user clicks. You can change the background color of the box, change the text font, count how many times the user clicks, and more. Click here in this box to see what you can do with the onClick attribute, and a little bit of JavaScript. When you combine JavaScript with HTML and CSS, you can make your web pages come alive. You'll notice that the developer uses the onClick attribute of the div tag to point to a JavaScript function called myClick function. This tells the browser to run that function when a user clicks the div element. Step 2. Next, the developer writes the JavaScript function to change the format of the text from normal to italic or italic to normal when the user clicks the text. Function myClick function. var element name equals document.getElementBid, click demo. If element name.style.fontStyle equals italic, element name.style.fontStyle equals italic. Else element name.style.fontStyle equals normal. This code uses the document.getElementBid function with the ID of the div element to find that div element. If the content of the element is not italicized, JavaScript italicizes it. If it is italicized, the function changes the content to normal, or non-italicized, text. Step 3. Finally, the developer adds a style sheet to their HTML file to set the color and size of the font in the div element to make it easier to read. They use an element selector to set the style. Div. Font weight bold. Color, black. Font size, 30px. The page is now interactive. The following animation shows the script in action. What do you think? This example simply shows how JavaScript changes the text from normal to italic. You've probably seen many web pages with much richer interactions. What is a way you can think of to use JavaScript to build dynamic web pages? Type your response in the following text box. Writing an answer is a good way to process your thoughts. These answers are for your use only. You have the option to download your response and save it. It will not be saved in the text box when you move on in the course. Evaluate your thinking. Does your answer account for the following? Does your idea consider that JavaScript can respond to all kinds of events, such as a user moving away from a text box after entering data in it or a mouse pointer hovering over a section of the page? And if your JavaScript code has location data, you can write an event handler that performs an action when a user arrives at a particular location. You can see all of the developer's code in the following code block. Take time to examine each line carefully to understand how the developer used JavaScript to make the page dynamic. Focus on the event listener and the event handler, and how the two work together to make the page dynamic. Div. Font weight bold. Color, black. Font size, 30px. Function myClick function. var element name equals document.getElementBid, click demo. // checks if the element style is italic. / sets the style to italic if it isn't. If element name.style.fontStyle equals italic. Element name.style.fontStyle equals italic. / if the style is italic, change it to normal. Else element name.style.fontStyle equals normal. The onClick event attribute reacts when a user clicks. You can change the background color of the box, change the text font, count how many times the user clicks, and more. Click here in this box to see what you can do with the onClick attribute and a little bit of JavaScript. When you combine JavaScript with HTML and CSS, you can make your web pages come alive. When using JavaScript on a web page, remember that even though many things can be done, it doesn't mean they should be done. Some dynamic interactions can detract from a positive user experience. For example, flashing text can be distracting and cause harm to those with photosensitivity impairments. Use JavaScript judiciously to make the user experience positive and useful. About this module. Module 2. The JavaScript Programming Model. Introduction. In this module, you'll learn the origins of object-oriented programming and how it compares to functional and procedural programming. You'll explore how JavaScript exhibits features of both object-oriented programming and functional programming, and look at the ways that web developers use these programming models to create code. Learning objectives. After completing this module, you should be able to differentiate between functional, object-oriented, and procedural programming. Describe a code object. Explain the features of a code object. Describe how to use a code object. JavaScript programming models. Web developers create JavaScript functions to respond to events on a web page. In fact, functions are an essential part of the JavaScript programming model. Categorizing JavaScript into a single programming model is difficult because it can work in a variety of ways. However, many programmers maintain that JavaScript mainly uses a programming model called functional programming. Functional programming uses functions to do work. When that work is done, the function sends control back to the code that called it. JavaScript can even send a function to another function. JavaScript also exhibits features of another prominent programming model called object-oriented programming, OOP. Object-oriented programming uses functions too, but the model is based on using code to create objects which have properties, data, functions, and other items. Like functions, programmers can reuse objects. Object-oriented and functional programming have been around for many years. Next, you'll explore why these technologies developed, which will help clarify why JavaScript developed in the way that it did. Spaghetti code. Imagine you're working as an assistant for a university catering company with 5 kitchens. Each kitchen produces different foods for the various campus cafeterias. When one kitchen runs out of an ingredient, your job is to replenish it from another kitchen. Your job is to provide the chefs with whatever they need, whenever they need it. Your job can get complicated. For example, Kitchen 3 needs salt, so you get salt from Kitchen 1. While you're delivering the salt to Kitchen 3, you're asked to provide oil for Kitchen 5, which you'll get from Kitchen 4. On the way to Kitchen 4, you drop the salt from Kitchen 1 and have to return to get more salt. You go back to Kitchen 1 because it's on your way to Kitchen 4, but then Kitchen 3 tells you they've run out of tomatoes and Kitchen 2 has plenty. You get the salt from Kitchen 1 to take to Kitchen 3 and then pick up the tomatoes from Kitchen 2 to take to Kitchen 3. You also can't forget about the oil Kitchen 5 needs. As you can see, this way of working gets messy. It would be a better process if you collected the salt from Kitchen 1 and delivered it to Kitchen 3 before you got an instruction from another kitchen. Early programmers ran into similar problems with programming. In the early days of programming, code was non-structured. This means that code processing started at the top of a code file and commands sent code to other parts of the file. This is a programming model called procedural programming. Each line of code in early programming languages had a line number. Programmers used a Godot statement to route code. Godot sends code execution to the specified line number to continue processing at that line. Here's a simple example of a program using line numbers and Godot statements. 10 print developers use HTML for page structure. 20 print developers use CSS for page design. 30 Godot 60. 40 print developers use JavaScript for page interaction. 50 print combining the 3 languages makes websites dynamic. 60 Godot 10. The numbers along the left side of the program are the line numbers. At the time, web developers would separate line numbers by 10 or even 100 in case they had to go back and add code between the existing lines. If they added too many lines and ran out of numbers, they would have to renumber every line. What do you think? Consider the flow of the program shown in the previous code snippet. When will lines 40 and 50 run? And, when does the program end? Type your response in the following text box. Writing an answer is a good way to process your thoughts. These answers are for your use only. You have the option to download your response and save it. It will not be saved in the text box when you move on in the course. Evaluate your thinking. Does your answer account for the following? The program code in the previous example will execute in the following way. Lines 10 and 20 of this program print text to the screen. Line 30 commands the program to go to line 60. Line 60 then tells the program to go back to line 10. Lines 10 and 20 of this program print text to the screen. So, this program never gets to lines 40 or 50 and continually loop printing the same two lines over and over until the programmer stops the program. A program loops when it runs the same lines over and over with no means to exit from within the program. Like your cafeteria experience, code like this got very messy. So messy in fact that developers named it spaghetti code because of all the routes the code could take and all the potential loops that can form. As computers became more popular and essential, computer engineers developed better ways to program them. Instead of programs that started at the top and ran to the bottom, engineers developed models where individual lines of code can be grouped, hold, and process data, and perform a specific function. These grouped lines of code also can be reused. Engineers called these groups of reusable code objects or code objects. Object-oriented programming. Programming using objects has been around since the early 1960s, but it didn't really become a standard until decades later. Code objects borrow a lot of concepts from biology. If you think of a plant or an animal as an assembly of complex parts that create a whole, you have a foundation for understanding how code objects work. A fish, for example, has a color, which is a property. It can swim, which is a function. It can take water into its gills, which is a type of input. It extracts the oxygen from the water and expels the water from its gills, which is a form of output. It can store food in its stomach and use it for energy. It can also create little fish who inherit all these properties, functions, input and output functionality, and storage capabilities from its parents through DNA. Even so, the fish's DNA is protected from modification from the outside world. The outside world can't change the fish's DNA, but it can influence it. The fish's DNA is encapsulated, which means it's protected from change while still allowing the environment to have some influence in how it gets passed along and what features it can express. Objects in object-oriented programs have many of the same features as the fish. In the next lesson, you'll explore some of these features and how developers use them to build code objects. Constructing code objects. Talking about software as an object might sound strange at first. How does an object exist in software? Consider a mobile device an object. It is an individual thing with a set of features that a person can use to accomplish tasks. Code objects are like that. Developers build and use them to do specific jobs, and the features they have enable them to do those jobs. Consider what a code object might look like for the task of logging into a website. 1. A web developer creates a code object that processes login information. 2. The object accepts the username and password as input. It includes code that checks the login information against data stored in a database to see if the username and password are valid. 3. After the code object checks the information, the object sends a success or failure message back to the user as output. All this can be done in a structural programming model, but the code object makes this process easier to manage and can help prevent bugs. It also enables other developers to reuse the code more easily. Let's continue to explore the features of code objects and how developers use them to build software features. Members. A member of a code object is any aspect or feature that enables it to store data or do work. Take for example the previous code object with the task of logging into a website. Members of that object include the data it can receive as input, the means by which it processes that data, the how, the output it returns to the user, the what. Here are some members that code objects can have. Constants. Constants hold data that can't be changed while the program is running. They are created by the programmer or by a setting that other programmers can modify and are used by the object when the code is running. For example, for a login object, a programmer might create a constant for how many times a user can try their username and password. The programmer might decide that 3 tries is the limit, and so they set a constant to tell the object to let the user submit their credentials no more than 3 times. Properties. A property is data that can be modified while the program is running. The password property in a login object holds the user's password data when the user enters their credentials into a form on the website. The program can use this property in other places in the login code object. For example, another object might enable the user to change their password, and this property can be modified in that object. Methods. Methods are code that do work. They are functions within objects. When a user submits their username and password, the software that checks their credentials against the information in the database is processed in a method. Events. An event is any action that occurs to or by the object. For example, when the user submits the form with their username and password, or when the object checks the credentials to see if they match the information in the database. Code objects are really useful because developers can reuse and extend them. They also support inheritance and encapsulation, which are features of an object-oriented language. Inheritance. If a developer makes a code object to support user login, another developer who also needs to provide login functionality can use the original login object on another part of the site. This is the reuse feature of code objects. They can even use the object to collect a username and password and then add another set of properties and methods to enable two-factor authentication. Two-factor authentication, or 2FA, requires a person to verify their identity using a mobile device or authentication app in addition to providing a username and password. The developer extends the object by adding a new method. In object-oriented programming, this type of reuse and extension is called inheritance. The new object inherits the members of the original object. And a programmer can extend the original object to add other functionality. You can think of a code object that supports inheritance like a document template. The template might include a place for you to add a title, a subtitle, a date, and the body text for your document. When you get the template, you want to extend it to include more items. In addition to the title, subtitle, date, and body text, you add a header and a footer to the template. Now when you create your document, you have the original 4 items plus a header and a footer. You inherited the original features of the template and extended it to make it more useful. Another way of looking at inheritance might be to look at fish. Regardless of whether the fish is large or small, whether it swims in the ocean or in a fish tank, it has some of the same basic properties as all other fish, like fins, gills, and scales. The general class is fish, and all instances of fish in this class, like bass, trout, and clownfish, inherit common properties of fins, gills, and scales from the fish class. This is similar to object-oriented programming, where a developer uses an original object, like the fish, and then creates a new object, like a bass, that reuses properties of the original object. Instantiation. In programming, developers call the process of creating a new code object instantiation. You might notice the word instance in that word. An instance of an object is a single version of whatever it is you're creating. The clownfish is an instance of the fish class. Instantiation in programming is the process of creating an instance of a code object. After a developer creates an instance, they can use it to do work in a program. The following image shows instantiation using fish. The class of fish possesses properties such as fins, gills, and scales, and they take in water and extract oxygen from the water. The image also shows 3 different kinds of fish: bass, trout, and clownfish. Each of these 3 different kinds of fish inherits the properties and functions from the main class of fish. The following image shows how a developer uses an instance in JavaScript. A login class possesses properties and methods. 3 instances of that class inherit the properties and methods of the original login class. Each instance has a different variable name, but they all instantiate the same class. These new instances enable a user to log into a website, an employee to log into another part of the website, and a customer to log into yet another part of the website. Encapsulation. Suppose the method for verifying the username and password uses encryption. A method in this context is the code that takes in data like the username and password, does some work, and returns a value or set of values. Encrypted text is a way of securing information so only the software using it can view it. A programmer might want to protect that method so programmers who use the code object can't change it. They can use the object's method, sending data to it and getting a result back from it, but they can't see how it does what it does and can't modify the code. Other features of the object can be modifiable. The object isn't modifiable, but the function of the object can be modified. For example, the length of the username property is a feature of the object. The object's developer can expose features of the username property like how many letters, numbers, and symbols or characters the user can use when creating their username. When another developer inherits the object, they can change this feature of the property to create different length usernames. You can think of encapsulation like using an ATM at a bank. When you use the ATM, the machine will let you view your balance, withdraw and deposit money, and make a transfer. These functions, or methods, are public because they're available for you to use. But the methods the machine uses to verify your personal identification number, your PIN, are not public. They are hidden to the user and only available to the people who build and maintain the machine. The following image shows a login class in JavaScript with 3 fields: username, password, and status. The developer added a method named setStatus to the login class that enables other developers to modify the status property after the class is instantiated. The developer of the login class only allows other developers to set the username and password when they instantiate the object because after a user logs in, their username and password should not change. In the encryption example, the developer protected the encryption code from other developers but exposed an attribute of the username property. Encapsulation is this ability for programmers to protect some aspects of an object and make others modifiable by other developers. You're learning a lot of new terms and concepts. Check your knowledge by matching the following descriptions of features of objects to the categories into which they belong. With this background in object-oriented programming, you're now ready to explore how functional programming works and compare it to object-oriented programming. Functional programming. Computer programmers view JavaScript as both an object-oriented language and a functional language. JavaScript is an object-oriented language because developers use it to create objects and modify them. JavaScript is a functional language because developers use functions for most tasks, including creating objects. A function is similar to a method in object-oriented programming. It is a set of code that can accept inputs, do work, and return outputs. To use a function, a developer calls it from other software code. Calling a function means to make the code in the function run. While functions are not associated with objects, methods are. For example, suppose a developer needs to respond to an error on their website. The error is an event. The developer can handle the event by calling a JavaScript function that produces an error message. Functions can also have constants and properties. But unlike code objects, the constants and properties are only used inside the function when the function is called. Its properties and constants are not available to the software as individual things like they are in object-oriented programming. JavaScript combines aspects of a functional programming model with features of object-oriented programming model. In JavaScript, functions are objects. About this module. Module 3. Overview of JavaScript structure. Introduction. This module provides an overview of the basic structure of JavaScript code. You'll learn that variables hold data and developers use them in functions. Functions are at the core of JavaScript programming and you'll explore their versatility in building dynamic websites. You'll also investigate how developers evaluate and assign data to variables and how websites use JavaScript to respond to changes on web pages. Learning objectives. After completing this module, you should be able to describe the role that variables play in JavaScript. Explain how functions operate in JavaScript. Define expressions and operators. Explain how to build an expression in JavaScript. Describe events and how developers use JavaScript to handle them. Variables. JavaScript is a powerful programming language used extensively to build dynamic and interactive websites. As you've learned, it has features of object-oriented programming as well as functional programming. Now, let's explore the role that variables play in JavaScript programs. A teacher stands at the front of a classroom teaching students who are sitting around tables looking at the teacher. Many children experience being reprimanded by a teacher for talking in class. They whisper something funny to a friend and both students start giggling, only to get a stern look from the teacher. Students have found a way around this, sending notes. Instead of leaning over and telling a joke to a friend, they scribble it on a piece of paper, fold it up, and pass it to their friend. JavaScript, along with most other programming languages, passes notes too. Think of a note as something that stores information. For the students, it can be a joke, an answer to a question, or the name of someone they like in the class. JavaScript's note-passing ability comes in the form of variables. Variables hold information or data. Many functions that a computer performs involve data, so programs need a way to hold and then modify that data. This ability to modify data is built into the word variable. The data can vary based on what the program needs to do. Declaring variables. Many programming languages require developers to declare a variable before they can use it. A declaration indicates the type of data the variable can hold. For example, if a variable will hold numeric data, a developer might use the keyword int to declare the variable. Declaring the variable in this way means it only can hold integer data. Integer is the data type. Software languages that support this type of declaration are called strongly typed languages because the data type can be declared. A language like Java might require that a developer use the keyword int to declare a variable that holds numeric data. Java is an example of a strongly typed language. A variable declaration in Java looks like this. Int mynumData equals 7. In this line of code, the variable name is mynumData and the data type is int. Notice that the declaration comes before the variable name. If the developer tries to store a string of text in that variable, the program will produce an error. JavaScript variable types. If a friend who is a native English speaker told you some significant news, and you said, "Wow, that's huge," they most likely would understand that you weren't referring to the size of something. Responding with the expression that something is huge in this situation means that the news is important and you recognize how significant it is. You recognize the context and respond accordingly. Computer screen displaying software code. JavaScript also uses context to work out how to handle data in variables. JavaScript is a weakly typed language. This means that developers don't need to declare a variable type before they can fill the variable with data. Like your use of the term huge, JavaScript uses context to deduce what type of data a variable holds. There are three primary ways that developers declare JavaScript variables: const, var, and let. Const declaration. Variables declared as a const hold data that can't be changed at runtime. For example, in a mathematical program a developer might use a const to store the value of pi. So instead of using the actual value throughout their program, they can use their const instead. A const variable can hold any type of data and the contents are called immutable data. Var declaration. Variables declared as var hold data that can be changed at runtime. They can hold any data type and JavaScript determines, or converts, the type of data the variable contains as needed based on the context. Let declaration. Variables declared using the let keyword typically have a value set when they're declared similar to a const. However, variables declared with let can be modified. For example, a developer might want a number to be incremented as a user clicks a button. The initial value would be set as 1 using the let keyword and then incremented by the user. Filling variables. Web developers fill variables with data by using an operation called assignment. They assign a value to the variable using the equal sign. In the following example, the code declares the variable named new variable as a var type and assigns the value of 2. var new variable equals to functions. You've already learned that a function is a set of JavaScript code that enables you to pass data to the code and get data back from it. When you have a conversation with someone, the other person responds after thinking about what you said. Your words are the input, their brain processes your input, and their response is the output. This is also how a function in JavaScript works. Basic use of functions in JavaScript. Suppose a developer is building a function that enables people to log into a website. The function takes the username and password as input and verifies the information, and then the output tells the user whether the username and password combination is valid. The following diagram shows how the function would work. The user enters their username and password on a form on the website. When they submit the form, the website sends the username and password to the JavaScript function, which checks the information to determine if it's valid. Here's how the function might look in JavaScript. Function login, username, password. Code to check credentials. If valid, return verified. Else, return sorry, not verified. Functions in JavaScript are very powerful and versatile. A standard function takes the input, does some work, and produces the output. Functions in JavaScript can also call other functions. Imagine that in the login function the design requires that the user enters their email address as the username. The developer might write a new function that checks whether the username is an email address. They then call this new function to validate the format from the first function. The following diagram illustrates how this updated code works. When the first function calls the second function to validate the format of the username, it passes the username to the second function. The second function takes the username as input and sends a message back to the first function telling it whether the format of the username is correct. Here's how the function might look in JavaScript. Function verify credentials, username, password. Const validated equals validate username, username. If validated equals false. Return sorry, not verified. Const valid password equals validate password, password. If valid password equals true. Return verified. Else, return sorry, not verified. Expanding the use of functions in JavaScript. As you have learned, object-oriented programming gives developers the ability to extend an object by adding new members. Web developers can extend a JavaScript function as well. To extend the capabilities of a function, developers use other functions. In JavaScript, using a function to inherit the features of another and then extend the new function is called prototyping. This is one way in which JavaScript exhibits features of an object-oriented programming language. JavaScript differs from other object-oriented languages because it uses functions as the backbone of many of its operations. Web developers call functions in JavaScript first-class functions. MDN WebDocs defines first-class functions as follows. A programming language is said to have first-class functions when functions in that language are treated like any other variable. For example, in such a language, a function can be passed as an argument to other functions, can be returned by another function and can be assigned as a value to a variable. Source, first-class function, opens in a new tab, MDN WebDocs. This definition emphasizes the role that functions play in a language like JavaScript. Other object-oriented languages create objects without using functions. In JavaScript, developers use functions to create objects. In object-oriented languages like Java and C#, the objects themselves are first-class. The following is an example of first-class functions in JavaScript on an e-commerce site. Var cart total equals function, cart items, tax fee, shipping fee, discount amount. Var total equals 0. 4, I equals 0, I cart items dot length, I plus plus. Total equals total plus item I dot cost. Total equals, total plus tax fee plus shipping fee, discount amount. Return your total is plus total. This example of code on an e-commerce site provides a total cost for a shopping cart. The output of the function is assigned to the variable cart total. The function totals the cost of the items in the cart. It then adds the tax and shipping costs and subtracts any discounts. It then returns the total amount and assigns it to the variable cart total. A function is useful here because the total of a shopping cart on an e-commerce website will vary. The total will change depending on what a person puts in their cart. The function does all the needed addition and subtraction, and the output of that function is the total. Instead of having to assign a number to the variable, developers assign the function to the variable and then can use that variable which runs the function in other places in their code. You're making great progress. Check your understanding of the characteristics of variables versus functions. Each performs very specific work in JavaScript. Expressions and operators. When you first learned about mathematics, you probably started with addition and subtraction. For example, you probably learned that 2 plus 2 equals 4. What you might not have learned is that 2 plus 2 equals 4 is an expression that uses an operator. Operators perform operations on variables. An operator, such as addition, is symbolized with the plus symbol, plus. The entire addition statement is called an expression, 2 plus 2 plus 4. Software languages like JavaScript use expressions and operators. Similar to expressions in mathematics, expressions in software can evaluate and perform operations with numbers using operators like addition and subtraction. Developers also use expressions to evaluate and modify text data. For example, JavaScript developers can use the plus symbol to join two pieces of text together. This joining strings of text is known as concatenation. Here's an example. var new string equals. JavaScript is a powerful language plus, and developers use it to make the web dynamic. The variable new string now contains the sentence, JavaScript is a powerful language and developers use it to make the web dynamic. The plus symbol in the expression tells JavaScript to join the sentences, called strings in JavaScript, to make a new sentence. Instead of using the two-part sentences in the expression, developers can assign them to variables and concatenate the variables to make the new sentence. The following example shows assigning the two-part sentences to two variables, string 1 and string 2, and assigning the concatenated string to the variable new string. var string 1 equals JavaScript is a powerful language. var string 2 equals and developers use it to make the web dynamic. var new string equals string 1 plus string 2. Special operators. You learned earlier that JavaScript uses the plus symbol to concatenate two strings of text. But JavaScript also uses the plus symbol to add two numbers together. For example, the variable new number in the expression, var new number equals 2 plus 2, will have the value 4. So, JavaScript determines at runtime which operation to perform based on the type of data in the variables. This is known as implicit type conversion. A man wearing headphones types code on his computer. Suppose a web developer needs to check the username that a person enters on a form on their website against a value from a database. They assign the database value to the variable dbuser and the value the user entered in the variable form user. Now the developer needs to compare the two variables to see if they match. Intuitively, you might think the equal sign is the correct symbol to use. But since JavaScript already uses the equal sign to assign values to variables, a special operator is used for comparative operations, the double equal sign. The following code sample compares the two variables, dbuser and form user. If they're the same, the code displays a message to the user stating that they're verified. Explore more. Check out W3 Schools, opens in a new tab. To learn about more types of JavaScript operators, see examples and try them out yourself. Using expressions with functions. Suppose you've been walking around a shopping center and get thirsty. You see a vending machine that dispenses water bottles. You put in some coins and type in the code A3 for the water bottle. You can think of the machine as a variable that you fill with information. The machine as a variable gets assigned the value of A3. But something else happens. You also expect the vending machine to do work for you. By putting in your money, you're telling the machine to retrieve the water bottle and give it to you. You've learned that in JavaScript functions are called first-class functions because of the central role they play in the programming language. You can assign a numeric or a string value to a variable, but you can also assign a function to a variable. Like the vending machine retrieving the bottle of water, a variable can request a JavaScript function to perform some work and send back information. Events. Software programs change constantly. They can change because a user interacts with them or because data is sent from a server. They can also change if an error occurs or a calculation completes. Developers refer to any change in a software system as an event. Web developers write JavaScript code to do work when an event occurs. Front of card. Event listeners. Click to flip. Back of card. Event listeners. They listen for a change to occur to an element. HTML elements can include event listener attributes that call JavaScript functions. An example of an event listener is an onClick attribute included in a button element. Event handlers. They respond to, or handle, the event. Typically, they're JavaScript functions that tell the browser how to respond. An example of an event handler is having a function that creates a pop-up success message when a user clicks a button. Take a moment to review the following code sample. In it, the button element has an onClick event listener that calls a JavaScript function called click function. The click function is the event handler. Click me about this module. Module 4. Interacting with data. Introduction. In this module, you will learn about using data from a web developer's perspective. You'll explore web data and different types of data types that developers commonly use. Because website data is usually stored in a database, you'll also explore the 4 primary database functions that developers use when working with data. And you will work through an example of creating, populating, querying, and updating a MySQL database. Learning objectives. After completing this module, you should be able to define data and common types of data. Identify the 4 primary database functions. Describe MySQL. Recognize simple MySQL syntax to create a database and work with data. Introduction to data. As humans, we need ways to share information and keep track of things like the passage of time, commerce, and education. Because of this need, written communications and mathematics have been around for thousands of years. But, as humanity has evolved and spread around the globe, the need for faster, more reliable methods of information sharing has increased. In fact, engineers and scientists have built the Internet and the World Wide Web to help meet this need. In computer science, data are pieces of information in a form that a computer can store and process. Computers take in data in the form of input, process it, then return the result to users in the form of output. On the web, data can be any information from the text and images on a web page, to sports scores stored in a database, to the username and password you use to log into a video streaming service. Imagine you are visiting your favorite website to purchase a candle as a gift. The website has a search bar into which you type candle. The web page refreshes and displays different candles that you can purchase. You select a candle and the web page displays information about the candle. You decide you want that candle, so you select the Add to Cart button. Alongside the information about the candle, the site suggests a few other items. You're interested in a few of those as well, so you select them and add them to your cart. When you have finished shopping, you begin the checkout process. You use your email address and password to log in, and the site immediately displays your saved credit card information. When you begin to type in your shipping information, the site asks you if you would like the website to have access to your location. You select Allow, and some information about your address is filled out for you. When you are ready to check out, a screen displays with your total cost, including the shipping fee and taxes. In this example, the website is using data in many ways. Search. As the user, you are giving data about what you would like to purchase to the website by entering data into the search bar. The website searches through all product data to display the matching items. Suggestions. The website uses historical data about previous purchases from you and other users to offer suggestions on additional items that might interest you. Authentication. You input data, including your email address and password, into the website and the website checks that information against the stored account information. The site might have other data attached to your account information, including your credit card details, so it provides that information back to you. Geolocation. By using data from your Internet Service Provider, ISP, the website gathers basic information about your current location. Performing calculations. Using the shipping information you provide, plus pricing, shipping, and tax rate information, the website calculates the order total. Websites generally gather data from two types of sources, a user or a database. User-generated data is any information that a user enters into a system. This is typically data from an input device, such as a mouse click, a voice command from a microphone, or letters or numbers from a keyboard. Websites also use data from databases. A database is a structured collection of data typically stored on a computer or server. Website databases might contain data that has previously been entered by users such as usernames, passwords, and email addresses, as well as information about what actions a user has taken on the website. They can also contain information specific to the website, such as product information for e-commerce sites, or research data to power charts on scientific or government sites. Types of data. Because websites use data to do so many different things, it's important for web developers to understand the most common data types that programs use. A data type is an attribute of a piece of data that tells a computer or program how to interpret the value. Web developers need to know data types to ensure that they collect data in the right format, and that the user enters the value for the piece of data as expected. For example, if you are filling out a form and it requests your birthday, it might be expecting a date in DD/MM/YYYY format. If you typed March 4, 1997 in the field, you would likely get an error. Programming languages each have their own set of primitive data types. A primitive data type is a set of high-level data types into which you can categorize all other data types. For example, numeric is a primitive data type which some languages divide up into other types for different sorts of numeric information, such as relatively small numbers, positive numbers, large numbers, and numbers with decimals. While each programming language has its own set of primitive data types, there are some common data types that are important to know. Since this is a course on JavaScript, the following table uses the JavaScript names of data types. Take time to study the following table. Boolean. Boolean data is any data that can have true or false values, with examples being false and true. Number. Numbers data is any data that includes number values, such as -100, 0, 100, 100.01, 100.00, and 0.01. String. String data is any data that is textual data, including characters and combinations of characters, digits, and symbols, with examples like hello, hello, world, and +1-800-888-8888. Unidentified. A variable is undefined when it does not have a value, for example, before a user enters their data, and when a computer evaluates a function and returns an undefined value, it returns undefined. Null. Null is a special data type that only has the value of null, typically used to represent a missing or invalid value, and is exemplified by null. Undefined data is another type in which data does not have a value yet, for example, before a user enters their data. Let's check that you understand the different types of data. In addition to collecting data, developers also need to perform operations on their data. Data functions. All organizations collect and manage data. For instance, governments can track voting and constituent data. Non-profits might collect and manage donor information or data about the projects they support. Corporations track data about their employees, their customers, and the products that they sell. This is just a small sample of all the kinds of data that organizations collect and manage. Any organization that tracks data needs systems for storing that data. Most organizations use databases to store their data. Databases are made up of one or more tables that might be related to each other. A table is a way of structuring and organizing data in a database. It consists of columns and rows. Organizing data in this way makes it easier to access and manipulate data. Tables are made up of records on each row, which are a group of related data stored in a table. Developers use 4 primary functions to implement databases: create, read, update, and delete, CRUD. Imagine you own a small cafe that has many items on the menu. You have some items like coffee and blueberry muffins that are always on the menu. You also offer some items that are seasonal, like peppermint mocha lattes in the winter, and a berry tart in the spring. You want to create a system to keep track of your menu items, so you create a menu database. In this hypothetical menu database, you might have a drink entity. An entity is a single thing about which data can be stored. In this example, the drink entity might contain name, type, price, and season. Let's use this cafe example to look at common database functions. Create. This is the operation you use to add a new drink to the menu. Imagine you have a new gingerbread latte for the winter season. You create a new item in the database that includes name, gingerbread latte. Type, hot coffee drink. Price, $3.99. Season, winter. Read. This operation enables you to view all the items you have on the menu. It retrieves the information from the database and displays the results. The read operation enables you to retrieve a single item, multiple items, or all the items. Update. This is the operation you use to update or edit information on the menu. For example, if the price of milk increases and you need to change the price of all lattes on the menu, you can use the update operation. Delete. This operation enables you to remove items from your menu. If you no longer want to serve tea at your cafe, you can call this function to delete all tea entries in your database. To perform these CRUD operations, web developers use a special language that databases understand, called Structured Query Language, SQL. Next, you'll learn all about SQL. Introduction to Structured Query Language. Just as HTML and CSS are standard languages that web developers use to create the front end of websites, developers use a standard language for creating and maintaining databases called Structured Query Language, SQL. Web developers use SQL to manage databases and perform operations on the data in those databases. While the International Standards Organization, ISO, maintains the SQL standard, there are some differences in SQL syntax depending on the database technology a developer is using. The examples in this lesson use MySQL. MySQL is a widely used open-source database management system suitable for both large and small database applications. As a programming language, SQL has commands as well as a syntax for issuing those commands. Review the following table showing the food menu items in the cafe. Table name, food_menu. Item ID 1 is a blueberry muffin, which is a baked good priced at $2.50 with no specific seasonal availability. Item ID 2 is a ham panini, which is a hot food priced at $5.25 with no specific seasonal availability. Item ID 3 is a berry tart, which is a baked good priced at $3.00 available in the spring. Item ID 4 is a cranberry yogurt parfait, which is a cold food priced at $2.75 available in the winter. Now let's look at the SQL syntax you can use to work with this data. SQL statements begin with a command and end with a semicolon, winky face. For example, this command will delete the ham panini from the food_menu table. Delete from food_menu where item name equals ham panini. Because MySQL determines the end of a statement by looking for a semicolon, developers can write complex SQL statements over multiple lines. For example, insert into food_menu, item name, item type, price, season. Values, baklava, baked good, 2.00, none. This command will add the following row to the food_menu table. 5 baklava baked good 2.00 none. SQL statements are not case sensitive, but it is best practice to write out SQL keywords in all caps. For example, select price from food_menu. Select price from food_menu. Both lines of code will return all the prices from the food_menu table. But the first select statement is written using best practices. As you have learned, SQL has a distinct syntax for writing commands. But what commands can web developers call with SQL? SQL has 3 primary command categories, or languages, which enable developers and database administrators to build, maintain, and use databases. Data Definition Language, DDL. Web developers use data definition commands to create and define databases and data tables. Common data definition commands include the following. Create. This command creates databases, tables, and more. Alter. This command modifies existing databases or tables. For example, you can use this command to add or remove columns in a table. Drop. This command removes existing tables from a database. Data Manipulation Language, DML. Web developers use data manipulation commands to modify data in tables in a database. Some data manipulation commands can be mapped to CRUD operations. Common data manipulation commands include the following. Insert. This command adds new records to a table, like the create operation in CRUD. Update. This command modifies existing records in a table. Delete. This command deletes records from a table. Data Query Language, DQL. Web developers use data query commands to find data in tables in a database. Following is the primary data query command. Select. This command displays the contents of a table, like the read operation in CRUD. You've learned about structured query language and some of the primary command categories of SQL. In the next lesson, you'll work through a scenario to learn how to write MySQL statements to define, manipulate, and query data. Using MySQL scenario. In the following scenario, explore the steps you might take as a web developer to create and manage a database using MySQL statements. Imagine you've just started working in a new back-end web developer role at a movie theater company. Before you can use movie data on the website, you need to get all the movie information organized into a database. Follow along to see the SQL statements you can use to create a database, create a table, add data to a table, read data from a table, update data in a table. Note, for this scenario, assume that you are using the command line interface, CLI, for your MySQL statements. A command line interface is a program on your computer that enables you to run programs using programming commands. On Windows machines, you might know the command line interface as the command prompt. On Mac machines, it is called terminal. You may also use different graphical user interfaces, GUIs, to write MySQL. A GUI enables you to communicate commands to your computer with the help of graphical elements such as menus, icons, and buttons. Create a database. To begin your first assignment, you need to create a new database using the following statement. Create database movies. This code creates a database called movies for you to add and manage your data. Notice the convention of using uppercase characters for the SQL keywords, create and database, and that the statement ends with a semicolon, winky face. Create a table. After you create the database, your next step is to create a table. Your manager requested that you include the following information about the movies in the database: movie title, release year, director's last name, country of origin, and duration in minutes. To create a table, you define the table name, column names, the data type that each column should expect, and for some data types the size of the field. The following statement creates such a table. Create table movie_info. Movie enum int. Movie title varchar, 100. Release year. Director last name varchar, 50. Country varchar, 50. Duration min_int. This statement creates a table in your database called movie_info with 6 columns. Movie enum to store an ID number using a numeric data type called integer, int. Movie title using a data type called varchar with a maximum of 100 characters. In MySQL, varchar is a string, text, data type. Release year using a data type of year. In MySQL, the data type year appears in a YYYY format. Director last name using a data type of varchar with a maximum of 50 characters. Country using a data type of varchar with a maximum of 50 characters. Duration min using a data type of integer. When table names consist of more than one word, it is standard convention to use an underscore between the separate words. And when column names consist of more than one word, it is convention to use camel case. Camel case is the method of omitting spaces and using a capital letter at the start of each word after an omitted space, for example, camel case. Add data to a table. Now you have a database, and a table within that database. Next you need to start adding data to the database. You have the following information to add. Table name, movie_info. Movie 001, the movie Les Parapluies de Cherbourg was released in 1964, directed by Demy from France, and has a duration of 91 minutes. Movie 002, the movie In the Mood for Love was released in 2002, directed by Wai from Hong Kong, and has a duration of 98 minutes. Movie 003, the movie Roma was released in 2018, directed by Quarren from Mexico, and has a duration of 135 minutes. To add this data, you can write the SQL statement. Insert into movie_info, movie enum, movie title, release year. Director last name, country, duration min. Values. 001, Les Parapluies de Cherbourg, 1964, Demy, France, 91. 002, In the Mood for Love, 2002, Wai, Hong Kong, 98. 003, Roma, 2018, Quarren, Mexico, 135. This adds all of your movie information into your movie_info table. Notice that you define which table and columns to insert the information into. This is also an example of a multi-line statement in SQL that uses commas to separate each row of data, and a semicolon to finalize the statement. Read data from a table. Now that you have some data in your table, you want to check the data to make sure that it is accurate. To view all of the data in your table, you can write the following SQL statement. Select asterisk from movie_info. The select statement returns the requested data in a table. The asterisk indicates that the program should return all columns. If you only wanted to see the movie titles and duration of movies from Mexico, you can rewrite your SQL statement as follows. Select movie title, duration from movie_info where country equals Mexico. This statement would return only movie title. Roma. Duration min. 135. You use the where keyword to define a condition for what data you want to retrieve. Update data in a table. When you review your data, you realize that In the Mood for Love film was released in 2000, but your table says it was released in 2002. To update the data in your table, you can write the following statement. Update movie_info. Set release year equals 2000. Where movie title equals In the Mood for Love. This will look in the movie_info table for the movie title In the Mood for Love and set the release year column to 2000. You must define the table and column to update and provide the new value for that column. It's important to note that the where clause determines which record, to update. If you omit the where clause, the statement will change all of the records in the table to have the release year set to 2000. Congratulations! In this scenario as a back-end developer, you used just a few simple commands to create a database so you can fill it with useful information. About this module. Module 5. Execution, Introduction to Node.js. Introduction. In this module, you'll explore the origins of web servers and how they have evolved. You'll learn about Node.js and the benefits it provides to web developers. You'll also learn about the benefits of using Node.js as a runtime environment and how using Node Packet Manager, NPM, can make Node.js more efficient. Lastly, you will discover some of the similarities and differences between frameworks and libraries and how developers use both depending on the need of their website. Learning objectives. After completing this module, you should be able to explain the functions and evolution of web servers. Describe Node.js. Identify how Node.js functions for web requests and fulfills them. Identify the benefits of Node.js and the importance of Node Package Manager, NPM. Compare and contrast frameworks and libraries. The power of web servers. When Orville and Wilbur Wright, the inventors of the first motor-powered airplane, flew their first airplanes, they took them to an open field to take off and land. An open field is the earliest version of a runway. An open field is very different from the commercial runways of today, where planes fly in and out of modern airports that have developed over decades as the aviation industry evolved. In addition to providing a place for airplanes to take off and land, airports do many other things, including refueling airplanes, repairing airplanes, and restocking supplies for flights. They move passengers and goods to and from airplanes and even provide restaurants for passengers waiting for their flights. Web pages, like airplanes, lose a lot of their usefulness without a mechanism to get them from one place to another. Developers use web servers to deliver web pages to users. A web server runs software that listens for requests and delivers pages to users that request them. When the World Wide Web was first developed, the first web servers were basic and only delivered simple web pages to a small group of people who made requests for them. The first web server ran on a single computer, and the biggest risk was someone accidentally turning off the power and shutting down the World Wide Web. As the World Wide Web evolves, the need for more powerful web servers evolves with it. One of the most powerful pieces of software that run on servers is Node.js, which is written in JavaScript. What is Node.js? Node.js is a JavaScript-based runtime environment that is freely available on the Internet. Developers can download and modify it without cost. This model of distributing software is known as open source software. As a runtime environment, Node.js runs on servers on the Internet and can be used to develop applications. One application is a web server that listens for requests for web pages. How does it do this? 1. When a user types a web address like https://www.ibm.com into their browser, they send a request to the web servers for that website. This is called a client-side activity because it is generated by a user or client. 2. When the user sends the request, the domain name service, DNS, on the Internet translates the web address to an IP address. An IP address identifies the location of the website using a 4-part numeric code. 3. DNS then directs the request to IBM's web servers. Those web servers are listening for requests. A server listens for requests by detecting when information is being sent to it. This is one way developers can use Node.js in a server environment. A web server built using Node.js continually listens for information being sent to it, and when it detects a specific type of request, it responds by sending a web page to the person who requested it. This is known as a server-side activity because the server is sending the web page to the client. Many of the topics you'll explore in this module are examples of server-side activities. Web servers deliver pages as a server-side activity, and web browsers show those pages to users as a client-side activity. The client and server depend on each other. Clients can't see pages without a server, and the server has no purpose if there aren't any clients to experience the pages they deliver. The browser makes a request, and the server fulfills the request. The client depends on the server for the data it needs. The server has to be listening constantly for requests so that when one is made, it's ready. The web server can never sleep, and it cannot be turned off. If that was to happen, it wouldn't get requests and fill them. The client initiates all the work the server does. If no clients make a request, the server has nothing to do. Next, explore the ways web servers running on Node.js detect and respond to web requests. Detecting a request. Suppose you're at a party with a room filled with people. You want to ask your friend to pass you some corn chips because they're standing by the table with the chips. Suppose you yell out, "Pass the chips." Your friend is listening to the other people in the room and might not hear your request because you didn't use their name. If you just yell out your request for chips, no one in the room will respond. You decide to solve this problem by texting your friend directly to ask them for chips. Web servers running on Node.js work by listening for requests. Browsers can send many requests to a Node.js web server, but it will only respond to their request if they ask in a very specific way. Web servers listen for requests for web pages using a specific protocol on a specific port. Like you texting your friend for chips, the protocol and port are using the web server's messaging app to get its attention. For web pages, the protocol is Hypertext Transfer Protocol, HTTP, or Hypertext Transfer Protocol Secure, HTTPS. The protocol sends the request in a specific way and tells the servers that run the internet what kind of request it is. The port enables the request to be routed to the web server. Ports are similar to the ways you can get your friend's attention at the party. One port is like a text message. Another port is like a phone call. A third port might be something like calling out their name. A web server with no open ports cannot accept any requests. Requests for web pages contact a web server primarily on two ports, 80 for HTTP requests and 443 for HTTPS requests. Fulfilling a request. When the web server knows that the request is of a certain type, such as delivering web pages, it can fulfill that request by sending data back to the user's browser. Most times, a request for a single web page involves sending many forms of data to the user's browser. For example, the web server sends text, images, and software code to your browser when you make a request for IBM's home page. Sometimes, when a runtime environment like Node.js fulfills a request, it sends JavaScript code to the user's browser to gather information. That code runs, gets the information the server needs, and then sends another request for more data to the web server. This is called making multiple round trips. It's like texting your friend to grab chips, and after they deliver them, they ask if you need anything else. "I'd like a napkin," you say, and your friend rushes back to the table to get one. The benefits of Node.js. Node.js was written to solve specific problems with clear design goals. One problem that Node.js addresses is efficiency when processing requests. Many web servers consume a lot of computer resources, especially when they receive a lot of requests. As a runtime environment, Node.js is designed to handle many requests quickly and efficiently. Explore other benefits of using Node.js as a web server. Node.js is written in JavaScript. JavaScript is the most popular language used on websites. Because Node.js is written in JavaScript, developers only need to learn one language that they can use when developing their web pages and on the server. Node.js is efficient with server resources. When a web server processes a request, it sometimes has to do other work in the background, such as retrieving information from a database. If that work takes time, it can prevent the web server from taking or fulfilling other requests while it waits. This is called blocking or deadlocking because the request blocks the server while it does the background work. Node.js is written to be a non-blocking environment. A web server running on software written with Node.js can avoid deadlocking by handing off background tasks to another application. The other application tells a web server to complete the request after the background work is done. This frees up the web server to take and fulfill other requests while the other application does its work in the background. Node.js is open source. Because all the code for Node.js is freely available, web developers can modify it to suit their needs. Web developers have written hundreds of additional libraries to extend Node.js. A library is a set of code that plugs into an existing application to extend existing features or add new features to the application. How do developers get libraries for Node.js? There is a special tool just for this purpose called Node Package Manager, NPM. You'll explore this tool in the next lesson. Node.js and the NPM. Imagine a bookstore with thousands of free books. When you walk into the shop, a computer at the front desk enables you to type in the name of any book in the library, and a robot finds and delivers the book to you. The robot even opens the book to the first page so you can start reading right away. That sounds too good to be true. It might be too good to be true for books, but NPM does something like this fictional library for web development software. It's a software package that finds, retrieves, and installs software from its catalog. And using NPM, web developers can extend Node.js and other web development tools using a large catalog of open source software. NPM doesn't just get software for developers to use, it also enables them to share the software they've written with other web developers. Additionally, it has community features so web developers can collaboratively work on software development and keep open source projects current and continually improving. Here are some things web developers can do with NPM from the project's website. Adapt packages of code for your apps or incorporate packages as they are. Download standalone tools you can use right away. Share code with any NPM user, anywhere. Restrict code to specific developers. Create organizations to coordinate package maintenance, coding, and developers. Form virtual teams by using organizations. Manage multiple versions of code and code dependencies. Update applications easily when underlying code is updated. Discover multiple ways to solve the same puzzle. Find other developers who are working on similar problems and projects. To use NPM, users must install Node.js on their computer. While using NPM in web development isn't necessary, many web developers have come to depend on the software. In fact, installing Node.js and NPM is, for many, a first step when developers set up a new computer for web development. Frameworks and libraries. JavaScript developers have made ready-to-use software. Earlier you learned about using NPM to install open source software. Software packages that you install using NPM are called frameworks and libraries. The softwares these two terms refer to are similar but have significant differences. Let's explore these similarities and differences. Similarities. Here are some ways that libraries and frameworks function in the same way in JavaScript code. They both contain JavaScript files containing code to perform specific tasks. For example, a developer might install a library or framework to help with page layout. They can both integrate into code web developers write. Libraries and frameworks are designed to supplement or enhance website code as developers author their sites. They aren't complete software capable of running a website by themselves. Both are distributed as open source software. Developers can freely install, modify, and use many libraries and frameworks to use them to develop their websites. Developers install both using NPM. Many popular libraries, like jQuery, and frameworks, like React, are available in the NPM catalog. Differences. Here are a few of the differences between a library and a framework. Libraries tend to be narrower in what they do. For example, a developer might use a JavaScript library to improve navigating the HTML DOM. This enhances what JavaScript already does and adds more features. Frameworks tend to add new features that native JavaScript doesn't have. Libraries don't use frameworks, but frameworks use libraries. Some frameworks, like React, use the jQuery library. One tool or code needing another tool or code to run is called a dependency. Libraries don't have dependencies on frameworks. Developers call the code in a library when they need to use a function from the library, or on demand. On the other hand, they will integrate a framework into the entire website, and it will change how the website functions. Developers use both libraries and frameworks depending on the needs of their website. Many major websites use and modify frameworks like Vue.js, Angular, and React to handle data processing and give their sites a look and behavior that is familiar to users. jQuery, a library that helps find elements and change them in the HTML DOM, is a popular library that is used all across the web. Libraries and frameworks can speed up development, provide common behaviors that users are familiar with, and because they are open source, the web development community is continually improving them. And they're free. You've come so far. And learned so much. You learned how to use JavaScript to create dynamic websites. You learned about the JavaScript programming model and how to use variables, functions, expressions, and events in JavaScript. You explored how to use data in a website and reviewed examples of MySQL code. Additionally, you learned about the purpose and function of Node.js and the advantages that frameworks and libraries provide. Now that you've completed this course, you should be able to explain JavaScript syntax, identify techniques web developers use to include JavaScript in HTML, compare and contrast different programming models, explain how to use code objects, explain how variables, functions, expressions, operators, and events operate in JavaScript code for dynamic websites, define common types of data, identify the 4 primary database functions, recognize simple MySQL syntax to create a database and work with data, explain the purpose and function of Node.js. Key points to remember. 1. JavaScript is a widely used programming language for front-end and back-end web development. 2. Web developers use JavaScript to create dynamic websites and respond to user-initiated events. 3. JavaScript exhibits features of both object-oriented and functional programming. 4. Objects have members, including constants, properties, methods, and events. 5. Object-oriented programming enables code reuse, inheritance, and encapsulation. 6. JavaScript uses variables to hold data or functions. 7. Different languages support different data types, but all have a set of primitive types from which others are derived. 8. JavaScript variables can hold any type of data and JavaScript is able to decide what kind of data it is when the program is running. 9. Boolean data can have true or false values, numbers data is any data that includes number values, string data is any textual data, undefined data is a variable that does not have a value, and null data only has the value of null. 10. Databases store data in tables, which are made up of records. 11. The 4 key database operations are create, read, update, and delete, CRUD. 12. SQL is the language that developers use to manage databases and perform data operations. 13. Node.js is an open-source, non-blocking, JavaScript-based web server. 14. NPM enables developers to extend Node.js and other tools using open-source frameworks and libraries.